All right, welcome to The Explainer. Today we're diving into something that sounds like it's straight out of science fiction, but it's a very, very real challenge for Bitcoin. We're talking about an existential threat from a new kind of machine that could, quite literally, crack its digital vaults wide open.
And that number you're seeing, that's not just some theoretical guess. That's the estimated value of Bitcoin that right now is sitting in addresses that are vulnerable to this new kind of quantum attack. We're talking hundreds of billions of dollars.
So, where is this threat coming from? Well, it's not from a movie. It's the very real and honestly rapidly approaching dawn of a new era in technology, the quantum era.
And this is the villain of our story, if you will, a CRQCs, a machine so powerful it just breaks the fundamental rules that keep our digital world safe. And here's the real kicker. Most experts believe a CRQCs could be a reality within the next decade.
Okay, so let's really get into the weeds here with this quantum threat. To understand the danger, we first got to look at how Bitcoin security even works and, where exactly the crack in its armor really is. So, you might be asking, where do these vulnerable billions even come from? It all starts with the magic at the heart of Bitcoin's security. This really beautiful piece of math. It's incredibly easy to make your public address from your secret private key. But it's supposed to be basically impossible for anyone to go backwards. That one-way street is the whole foundation, and that's exactly what a quantum computer threatens to just blow right through. And with a quantum computer, that vital security assumption, it completely shatters. A job that would take the world's best supercomputer longer than the age of the universe suddenly becomes doable in just a few hours or days. The digital lock is, for all intents and purposes, broken. And the scale of this vulnerability is, well, it's massive. We're talking about roughly a third of all Bitcoin that will ever exist. These are funds sitting in addresses where the public key is out in the open, making them prime targets for this kind of attack. So who is in the crosshairs here? Well, the most at-risk funds fall into a few key buckets. You've got the oldest coins, some mined by Satoshi himself, which use an address format that just exposes the public key. Then you have funds where people have reused addresses, something a lot of exchanges and big institutions used to do, which leaves that public key exposed on the blockchain forever. Okay, so this all sounds pretty dire, right? But it's not a complete doomsday scenario with no solution. The crypto community has actually been preparing for this for years. So now let's look at how Bitcoin can actually forge some new armor to defend itself. The answer is a whole new generation of digital security called post-quantum cryptography, or PQC for short. These are basically new kinds of digital locks built on totally different math problems that we believe are hard for even a super powerful quantum computer to crack. But like most things, there's a trade-off. This new, tougher armor comes at a cost. Post-quantum signatures and keys are way, way bigger than what Bitcoin uses today. A Lamport signature, for example, is over 100 times bigger. And that has real-world consequences, Bigger transactions mean higher fees and potentially a slower network for everyone. And this isn't just a Bitcoin problem. Not by a long shot. This is a global scramble. Governments and big industries all over the world are in a full-blown race to upgrade their critical systems. The US government, for instance, wants to phase out the old stuff by 2030. It's this massive coordinated effort to get ready for what's coming. And this is where things get really interesting. We're moving beyond a purely technical problem and into a deeply philosophical one. The solution actually creates a new problem that gets to the very heart of what Bitcoin is all about. So here's the big, thorny question. What on earth do you do about all those vulnerable coins? The Satoshi-era coins, the coins people lost their keys to, the ones that literally can't be moved to a new, safe address by their owners. This question has kicked off one of the fiercest debates in the community. And right now, the community is basically split into two camps. The burn it side says we should just upgrade the network to make those old, vulnerable coins impossible to spend. They see it as a kind of bug fix to stop a catastrophic theft. But on the other side, the let it be stolen camp says, whoa, hold on. Any intervention from the network is basically confiscation, and that violates Bitcoin's core rules. For them, not your keys, not your coins is the law of the land, even if the threat is a quantum computer. And the respected developer Jameson Lopp really nails the burn arguments here. He basically frames it as a choice between letting a massive, unfair wealth transfer happen or stepping in to protect the system. It's a choice between letting tech progress decide who gets billions or preserving the original property rights.
Okay, so we've got this huge technical hurdle and this massive philosophical debate. So, what's the actual game plan? What's the path forward in this race against time? First things first, let's talk timeline. What's our deadline here? Well, the general consensus among experts puts the arrival of a CRQ somewhere between 2030 and 2035. So that gives the community a window to act. But it's not a huge one. The clock is definitely ticking. So the strategy that's being floated is actually pretty smart. It's a two-pronged approach. Track one is like an emergency plan, a fast, two-year project to get a basic defense up and running, just in case quantum computers get here faster than we think. And at the same time, there's track two, a much slower, more careful seven-year path to build and roll out the perfect long-term solution. And make no mistake, this long-term path is a marathon, not a sprint. It means years of research and debate just to get everyone on the same page, then more years of intense coding and testing. And after all that, you still need a multi-year push for the entire ecosystem, wallets, exchanges, users, to actually make the switch. It's a huge undertaking, on the same scale as massive past upgrades like SegWit and Taproot.
So at the end of the day, this whole quantum threat, it's so much more than just a technical upgrade. It's forcing the Bitcoin community to make some really tough choices about its core values and its future. The tech is a challenge, the timeline is a challenge, but maybe the biggest question of all is a human one. Can this global, decentralized community actually come together to solve a problem this big before it's too late?